One of the major misconceptions about isolating or weatherproofing or insulating is that we're going to waterproof the joint. In principle, these connectors are actually waterproofed already. Water can't really get in there, so they're already well isolated. What we must really do is to protect the joint against the weather and from vibrations. When wind or temperature changes cause movement, metal expands. There's a possibility that connectors could become loose. So we cover these things with a self-amalgamating tape that grips the joint all the way over it, and it prevents these things from coming loose no matter what vibrations or temperature changes they're subjected to. The electrical insulating tape protects the self-amalgamating tape. If we look at a little piece of feeder, we see that there's a hole in the end. The feeder is hollow. This means that the length of feeder will contain a volume of air. So during cycling of the weather, in hot weather, there will be a pressure built up which will force air out of the feeder. Then when the weather cools down, it will create a vacuum which will draw cold, damp air into the feeder. And that moisture can cause corrosion. And if you have two pieces of metal in contact with corrosion, you create a semiconductor junction which will rectify, it will create harmonics, it can cause intermodulation on sites with other transmitters. And in general, you can get a mega failure. So we have to avoid moisture at all costs. And we do this by effective insulating of the cable. Ericsson will provide for you a sealing set with the installation materials. And the sealing set involves the PVC insulating tape and also a self-amalgamating tape that you'll be using for the job. It also contains a set of instructions that tell you exactly how to use it all. The self-amalgamating tape, by the way, is often known by other names. It could be called self-vulcanizing tape, self-fusing tape, or even self-bonding tape, but it's all the same material. Self-amalgamating tape is perhaps one of the most common words. Here we have a junction between a feeder cable and a jumper cable. And this jumper cable is connected with the normal 7/16 inch connectors. You'll notice that there's already a piece of plastic as a part of the jumper cable, and this is a part of the junction. This must be included in the junction, so you must tape beyond it 5 centimeters. So we are taping from here to here. We will begin with one layer of the self-amalgamating tape, and we'll be winding it from bottom to top. However, this connector, I've left it loose, it should be tightened, but you can see that it's tightened in a clockwise direction. If we now draw the tape in an anti-clockwise direction, it will tend to undo the connector. So it must always be taped in the direction the connector is tightened. If this jumper cable was to be fitted to, let's say, a TMA, then it will be wound the other direction. But this one is tightened this way, and we're going to wind it from bottom to top in a clockwise direction. I'll just tighten this to the correct torque before we do anything else. The self-amalgamating tape has got a protective backing, and this prevents the tape layers from fusing together on the roll. And we start off 5 centimeters below, and we begin taping on the way up. When we wrap the tape around it, we must overlap every layer by 50%. And we must overlap it as we wind up the cable so that the layers overlap on the outside, just like the tiles on a roof. As you can see, while we're binding this, I'm pulling the tape tight and actually stretching the tape so that it fits well into the depressions and the contours of the connector. This is most important so that we can avoid any air pockets or even any channels that will allow air to move in or out of the connection. Notice how I'm taking care to ensure that the tape does not become twisted, for if the tape becomes twisted, then it will create a channel that will allow air into the joint. Okay, that's the self-amalgamating tape. It starts 5 centimeters before the junction and it finishes 5 centimeters after the junction on the cable. Every joint is on top of the previous and every lap is overlapping by 50%. We've got one layer of self-amalgamating tape, and now according to the instructions we will add 2 layers of PVC electrical insulating tape. By the way, do you know why we use PVC electrical insulating tape? Well, self-amalgamating tape, it could get hot and become more malleable, more soft in the sunlight, but over a period of time it can even harden and crack. And so the PVC electrical insulating tape is a tape that protects this self-amalgamating tape. You'll notice how I've started below the level of the self-amalgamating tape. I've started roughly 3 centimeters before the self-amalgamating tape. Again, I'm winding it in the same direction so as to tighten the connector. I'm covering completely the self-amalgamating tape and every turn is overlapping by 50%. So we continue taping the joint and we give it 2 layers of PVC electrical insulating tape. Okay, now I've used the PVC insulating tape. I've gone 3 centimeters over the end. I've not cut the tape off and I'm going to continue back down again. A second layer of PVC tape. When you are putting the tape on though, don't pull it too tight. If you pull it too tight, then with some of the amalgamating tapes that are available, you can cause them to squeeze out through the joints. With this particular tape though, provided by 3M, there's not much danger of that, but you still should only use enough pressure, enough tension, so that this thing fills in any gaps and the tape is not allowed to fold over, otherwise it would create an air channel once again. We must avoid that at all costs. So I shall continue back down in the opposite direction, pulling it only as tight as is needed. The last couple of turns, there's virtually no tension on them whatsoever. I've not stretched at all, so that there's no stress to try and peel the tape apart. It sits naturally, it's locked quite nicely, and I've covered from 3 centimeters before the self-amalgamating tape. I've gone over the amalgamating tape by 3 centimeters, a little more, it doesn't matter. And then I've come back down the opposite direction so that it's got 2 layers of PVC tape covering the self-amalgamating tape. And there we have a good joint. A good joint properly insulated has got to last for at least 10 years, but if it's properly insulated it could last much longer than this, maybe up to 30 years or so. But 10 years is always the goal, it should last for 10 years. We're going to show you how to fit the 3M cold shrink termination protection for cables and joints. And this particular cold shrink is in the Ericsson product portfolio and is approved for use by Ericsson. This consists of a rubber tube with a padded section, and the assembly instructions for it are usually given with the product. Basically, you push it over a junction or a connection and then you pull out the nylon cord and the pre-stretched rubber tube will shrink and grip the cables. The padded section must be fitted over the connector. So this particular piece is great for the connections at the bottom of antennas. Right now though, I'm going to connect a jumper cable to a feeder cable, and I'm going to use this one, which has got a padded section in the centre. This would be done in a dry atmosphere, that is to say there's no rain or we are protected from the weather. So we remove the caps, ensure we don't get any moisture into the connector. Don't forget to feed it on before you make the connection, and connect the jumper to the feeder. All of these connectors are connected and tightened to a specific torque. This one is no exception. At this stage in the real world, you would test the radio base station and the antenna system to make sure that it functions. If there's any faults, it can be rectified before the connection is isolated. We'll assume that this has been tested and it's working correctly. So now we just slide this and we position the padded section over the connector, and then we start to pull out the nylon cord as we wrap it around the feeder. From time to time you might get a little bit too much of this nylon band around the cable, so just cut it off, and it helps to make life a little easier when you are pulling the thing. Anyway, there we have, we've pulled the nylon band from inside the rubber tube and it's contracted and gripped the joint. The joint is now sealed watertight. Now we're going to isolate the connection to an antenna. It doesn't really matter what it is, it's the fact that this is a connector flush against the surface. And so we're going to use the cold shrink, and we select the one with the padded part at the end. Before we actually fit this permanently, we should actually test that the feeder, jumper and antenna is in fact functioning and that there's no faults on the base station, because it's difficult to take away the sealing if you need to correct a joint. Once again, before we remove the caps, we must make sure that we are in dry weather, or we're at least protected from moisture, because we can't allow moisture to go up these connectors or down these connectors. Connect the connector exactly the same as you would normally, but don't forget to put the cold shrink over the jumper first. Okay? I know that I've connected the correct jumper cable to this particular antenna because I've already marked it. And as normal, you tighten these to a specific torque. We push the cold shrink over the joint and we hold it up against the bottom of this panel whilst we draw the cord out of the bottom. And the rubber, which has been pre-stressed, will shrink and protect the joint. Notice how we're still continuing to press this up against the bottom panel. And there we have a properly insulated joint. There's no possibility of water or moisture getting into that. And of course, we have to fit the second jumper cable to RXA.